study of motion. In previous lecture, we complete graphical study of motion. First point we completed, that is object is at rest. When object is at rest, then its graph is horizontal straight line, that means parallel to time axis. That means its velocity or displacement of object is 0. Therefore, we get horizontal straight line along t axis. Today, we start with object with uniform velocity along positive x axis. So, we are going to study uniform velocity along positive x axis. So, this is two coordinate system xt. We call this graph as a xt graph. This graph is xt graph. Now here x means displacement. Here, give concentration students. X means displacement and t for time. Displacement time graph. Now we know that displacement, that means x divided by time, we get velocity. The formula for velocity is v is equal to displacement divided by time. So, along y-axis there is a displacement of object in meter. 2 meter, 4 meter, 6 meter, 8 meter. And along time axis there is time 5 minutes, 10 minutes, 15 minutes, 20 minutes. Now when the object is at rest position, that means at 0 coordinate, and travels after 5 minutes, it covers 2 meter distance. It covers 2 meter distance. After 10 minutes, it covers 4 meter distance. After 15 minutes, it covers 6 meter distance. So, this time has equal distribution. That means from 0 to 5, there is 5 minutes, from 5 to 10, 5 minutes, 10 to 15, there is 5 minute distance, 15 to 20, there is 5 minute distance. Now see on displacement axis, there is 0 to 2, 2 meter, 2 to 4, 2 meter, 4 to 6, 2 meter, that means equal dividation of meter and also equal dividation of time. Now the object travels through after 5 minutes, it covers 2 meter distance, and when we join these points, we get a straight line. We get a straight line graph. It indicates that this straight line indicates that there is equal distance in equal time. Object covers equal distance in equal time interval. Therefore, the object motion is equal interval of time and equal distance, or we say it as the equal displacement of object in equal intervals of time. In equal intervals of time, that means the motion of object is uniform along x and t axis. I repeat again, the motion of object is uniform because on this straight line, when we take a slope of the line, we get the constant slope of this line. That means there is a uniform velocity. We get uniform velocity along positive x-axis. Now the graph is displacement and time. And we write here uniform velocity. We know the ratio of displacement, that means delta x divided by delta t, displacement dx divided by dt, we get velocity. we get velocity. Therefore, we write here uniform velocity along positive x-axis. The slope of the velocity line we get along positive coordinate system of this x and t graph. Positive x-axis. So velocity is also positive. Displacement of object in equal intervals covers equal distance. Therefore, we call it as a uniform velocity of object along positive x-axis. In this xt graph, we get uniform velocity, and there are some points to remember, important points to remember from this graph. Is first point, when the particle moves, the position of the particle changes with respect to time. When the particle moves, position of the particle changes with respect to time. Second point, equal change in position in equal intervals of time. Equal change in position. For example, if this is a 2 meter in 5 minutes, then next 2 meter in 5 minutes. This point is important. There is equal change in position. Equal change in position of object in equal intervals of time. Therefore, graph is a straight line with respect to positive slope. With positive slope, and delta x divided by delta t, that is change in position. Delta x, that means change in position with respect to time in which taken place. Time in which change takes place. Delta x divided by delta t, and slope is constant, and it gives the average velocity. Slope of this graph is constant. Slope of this graph is constant, and which gives us the average velocity. The average velocity and instantaneous velocity of the particle are equal. Average velocity and instantaneous velocity of this particle or object is equal. So this is the graph of uniform velocity along positive x-axis. ठीक आहे विद्यार्थी मित्रांनो, हा ग्राफ समजला असेल तुम्हाला. तर आपण नेक्स्ट ग्राफ पाहणार आहोत. या ग्राफ मध्ये इक्वल इंटरव्हल्स ऑफ टाइम मध्ये डिस्प्लेसमेंट ऑफ ऑब्जेक्ट सुद्धा काय होत आहे, इक्वल होत आहे. प्रत्येक 5 मिनिटानंतर तो ऑब्जेक्ट इक्वल डिस्टन्स कव्हर करतोय, म्हणून त्या ऑब्जेक्टची मोशन जी आहे ती मोशन काय असणार आहे, युनिफॉर्म असणार आहे अलॉंग पॉझिटिव्ह एक्स ॲक्सिस. सो नेक्स्ट ग्राफ आपण पाहणार आहोत, दॅट इज द ग्राफ ऑब्जेक्ट with uniform velocity along negative x-axis. Negative x-axis, and a representation of this graph is like this. This is the time axis and this is the displacement axis x. We know if we take the ratio of displacement divided by time, we get the velocity. Therefore, we write here object with uniform velocity along negative x-axis, and the slope of the graph is like this. The displacement or motion of the object along negative x-axis. Therefore, the object displacement is like, slope of the line is like this. From this graph, we study or we learn that as the time passes, for example, if there is a 2 minute or if there is a 5 minutes, then 10 minutes, then 15 minutes and 20 minutes we have taken, and as the time passes, as 5 minutes passes, the object travels in negative x-axis. The displacement of object along the negative x-axis. For next 5 minutes, it travels along the negative x-axis. For next 15 minutes, it travels along the next negative distance. Therefore, and if we join these points, we get the line, decreasing line of the motion of that object. So, this object with a uniform velocity along the negative axis, we get like this. As the time passes, object reverses downward. The motion of the object in downward direction. Therefore, we get the uniform velocity along negative x-axis. There is a word, important word, uniform, that means in equal intervals of time. Listen carefully. In equal intervals of time, the displacement of object is along the negative x-axis. So, important point of this graph, remember, first point is this position type graph of a particle moving with a negative velocity. Moving with negative velocity. Moving with negative velocity. Because along negative x-axis, so the displacement delta x, displacement divided by time, we get minus. So moving with a negative velocity. Second important point, displacement decreases with increase in time. Displacement decreases. Displacement decreases with increasing in time. Increasing in time. Increasing in time. See, time increases. After 5 minutes, 10 minutes, 15 minutes. That means time increases, but displacement of object is decreases. So if there is a minus 6 meter, here is minus 4, minus 2, minus 1, like this. That means displacement of object as the time passes decreases. So we write here displacement decreases with increase in time. This is the important point for a uniform velocity along negative x-axis. Next point is slope of the graph is negative. Slope, that means delta x divided by delta t. The slope of the graph is negative. And next important point, slope is negative. I write here slope of the graph is negative. And next important point of this graph is it indicates that the velocity of the particle is negative. Velocity of that particle or object is negative. So the average velocity of particle can be positive or negative depending upon the displacement. See, these two graphs are representing positive velocity as well as negative velocity of object. These graphs represent positive velocity, positive uniform velocity of the object, and this graph represents negative uniform velocity of the object. So next point is, next graph is point number D. Object performing oscillatory motion. Object performing oscillatory motion. oscillatory motion. So along x and time axis again, because we know that ratio of x divided by t, we get velocity and object performing oscillatory motion. So what is meant by oscillatory motion? Oscillatory, for example, a pendulum attached with a lightweight thread, and if we give it motion, जर आपण त्या ऑब्जेक्टला त्या पेंडुलमला मोशन दिली तर तो काही पेंडुलम आहे तो पेंडुलम टू अँड फ्रो मोशन मध्ये काय होणार आहे, व्हायब्रेट होणार आहे किंवा ऑसिलेट होणार आहे. ऑसिलेट आपण वर्ड यूज करूया. तो पेंडुलम जो आहे तो पेंडुलम टू अँड फ्रो मोशन मध्ये अशा पद्धतीने ऑसिलेट होणार आहे. जर पार्टिकल किंवा ऑब्जेक्ट जो आहे तो ऑब्जेक्ट अशा पद्धतीने ऑसिलेट होत असेल तर ग्राफिकल रिप्रेझेंटेशन आपण त्या ऑब्जेक्टची जी काही मोशन आहे ती ऑसिलेटरी मोशन ती ग्राफिक्सच्या सहाय्याने आपण कशा पद्धतीने दाखवणार आहोत ते या ग्राफवरून आपण पाहणार आहोत. ठीक आहे. फॉर एक्झाम्पल हा पेंडुलम आहे आणि तो पेंडुलम एक पॉइंट पर्यंत नेलेला आहे आणि तिथनं आपण त्याला मोशन दिली तर एक पॉइंट पासून दिल्यानंतर तो काय करणार आहे, डिस्टन्स कव्हर करणार आहे आणि बी पॉइंट पर्यंत गेल्यानंतर बी पॉइंट पासून परत तो ए पॉइंटला येणार आहे. This type of motion is called as a oscillatory motion, and that oscillatory motion along x and t axis. Along x and t axis. For example, object जो आहे तो object या पोझिशनला आहे. This is the origin coordinate of x and t axis. आणि त्या ऑब्जेक्टला आपण ऑसिलेशन्स देतोय, मोशन देतोय. तर मोशन दिल्यानंतर त्या ऑब्जेक्टचं जे काही ग्राफिकल रिप्रेझेंटेशन असणार आहे ते ग्राफिकल रिप्रेझेंटेशन अशा पद्धतीने झिगझॅग मोशन मध्ये आपल्याला मिळणार आहे. दॅट मीन्स द सुरुवातीला आपल्याला ऑसिलेटरी मोशन किंवा ग्राफिकल रिप्रेझेंटेशन जे आहे ते पॉझिटिव्ह मिळणार आहे, नंतर ते डिक्रीज होणार आहे, नंतर पुन्हा ते इन्क्रीज होणार आहे. दॅट मीन्स दिस पॉइंट शोज for example, this is the time axis, and if we take a time 5, 10, 15, again 20 like this for a minute, then for first 5 minutes, if it take as a increasing, then next for 5 minutes it gives a decreasing motion, and next for 5 minutes it gives increasing motion, next 5 minutes it gives decreasing motion. That means to and fro motion, up and down motion. अशा पद्धतीने तो ऑब्जेक्ट जो आहे तो ऑब्जेक्ट ऑसिलेट होणार आहे आणि तो ऑसिलेट झाल्यानंतर आपल्याला जे ग्राफ जो आहे तो ग्राफ आपल्याला अशा पद्धतीने मिळतो. दिस इज द एक्स ॲक्सिस डिस्प्लेसमेंट अँड दिस इज द टाइम ॲक्सिस. त्या ऑब्जेक्टचं जे काही मोशन आहे ती विथ रिस्पेक्ट टू टाइम असणार आहे, त्यामुळं ते ग्राफिकल रिप्रेझेंटेशन जे आहे ते आपल्याला अशा पद्धतीने मिळते. द xt graph, here we have to remember 2 points, that is xt graph of an object having oscillatory motion with a constant speed. त्याचा जो स्पीड आहे स्पीड काय असणार आहे, कॉन्स्टंट असणार आहे. अँड सेकंड पॉइंट दॅट वी आर गोइंग टू रिमेंबर the direction of velocity change from positive to negative and vice versa. Direction of velocity changes. This point is important. Direction of velocity changes from positive to negative and vice versa. याच पद्धतीने ती मोशन जे आहे ती मोशन काय होणार आहे, रिपीट होणार आहे. इथे जर आपण पॉझिटिव्ह कन्सिडर केलं तर हा हे जी मोशन आहे ती काय असणार आहे, निगेटिव्ह असणार आहे. पुन्हा ती काय होणार आहे, पॉझिटिव्ह होणार आहे. पुन्हा ती काय होणार आहे, निगेटिव्ह होणार आहे. दॅट मीन्स रिपिटेशन सायकल ती होणार आहे along the motion, along the distance. So this type of graph we get as a direction of velocity changes from positive to negative and vice versa. That means when the object is in oscillatory motion, we get the nature of the graph is like this. So next graph that we are going to study, that means object in non-uniform motion. When displacement of object or object travels in a non-uniform motion. E, point number E, object in non-uniform motion. Non-uniform motion. So non-uniform, that means displacement of object is random, belongs to next physical quantity. For example, uniform motion, that means the object motion is like this, and non-uniform motion is like this, randomly. This motion we call it as a non-uniform motion of the object, and this motion along the straight line, that means uniform motion. This is called as a uniform motion of object, and this is the non-uniform motion. So we have to plot a graph, or we have to show the relation between two physical quantities which are non-linear motion or non-uniform motion. So this is the x-axis. This is the time axis again, because the object motion of the object with respect to time, as the time passes the displacement gets occurs. So we have taken with motion of the object with respect to time, therefore this is the time axis, and this axis is the displacement axis as a x. So object in non-uniform motion, along this axis we get the motion of the object like this, type of curve. This is the starting point, and this point is end point of that object. So if we join this point from A to B, we get this straight line. That means the motion of the object is start from this point and end at point. So displacement is from point A to B. Displacement from point A to B, and belong to this direction there is 2 points C and D. If we take a tangent line like this, so this time we taken as T1, T2, T3, and at point B where the particle or object stops, that is a T4. Now at a point A, displacement of object is x1. At a point C, displacement of object is x2. At a point D, displacement of object is x3. And at a point B, displacement of object is x4. The position of object is x1, x2, x3, x4. And the time passes when the object is at distance x1, it covers time t1. When object is at x2, it covers at time t2. When object at x3, it covers time t3. And when object is at x4, it covers time t4. Now, if we take a tangent, or if we want to find out the slope of this motion of the object, then we draw this tangent to this curve and we get the slope of this graph at t0. We get the slope of the graph at t0. See the motion of the graph. The object start from A, it covers some point C, then D. The motion of the object, see by this graph, A to C, then C to D, and then D to B. There are different paths. There are different paths covered by that object, and this motion of object is non-linear. See, A to C, there is different path. C to D, it covers the path is different in different time. and D to B there is a different path and it covers in different time. So the particle or object start from A and stop at point B travels in a different path distance. Travels in a different path distance, and this motion of the object we call it as a non-uniform or non-linear motion of that object. या ग्राफात आपल्याला समजतंय की ऑब्जेक्ट जो आहे तो ऑब्जेक्ट ए पॉइंट पासून सी पर्यंत येताना त्याची पाथ लेंथ आहे किंवा डिस्टन्स कव्हर केलेलं आहे ते वेगळं आहे. सी पॉइंट पासून डी पॉइंट पर्यंत त्याने डिफरंट पाथ लेंथ यूज केलेली आहे आणि डी पॉइंट पासून बी पॉइंट पर्यंत त्याने वेगळी पाथ लेंथ यूज केलेली आहे. दॅट मीन्स द मोशन ऑफ द ऑब्जेक्ट इज नॉट लिनियर. त्या ऑब्जेक्टची मोशन जी आहे ती मोशन लिनियर नाहीये, नॉन लिनियर मोशन आहे असं आपण म्हणतो. दॅट मीन्स नॉन युनिफॉर्म मोशन. मोशन ऑब्जेक्ट इन अ नॉन युनिफॉर्म मोशन. जर ऑब्जेक्ट नॉन युनिफॉर्म मोशन मध्ये असेल तर त्याची ॲव्हरेज व्हेलॉसिटी जी आहे, ॲव्हरेज व्हेलॉसिटी आपण कशी काढतो तर त्या जो काही डिस्टन्स कव्हर केलेला आहे त्याचा आपण स्लोप घेतो. आता हा जो A टू B पॉइंट आहे तो आपल्याला कर्व टाइप दिसतो आणि तो जो कर्व आहे त्याला जर आपण टॅन्जंट टाकला तर त्याचा आपल्याला स्लोप मिळतो. म्हणजेच आपल्याला त्याची ॲव्हरेज व्हेलॉसिटी जी आहे ती ॲव्हरेज व्हेलॉसिटी मिळून जाते. So from this graph we have to remember some important points. First point, या ग्राफवरून तुम्हाला समजलं असेल की तो ऑब्जेक्ट जो आहे तो ऑब्जेक्ट नॉन लिनियर मोशन मध्ये आहे किंवा नॉन युनिफॉर्म मोशन मध्ये आहे. तो ऑब्जेक्ट इक्वल टाइम मध्ये इक्वल डिस्टन्स कव्हर करत नाही, म्हणून आपण त्या ऑब्जेक्टची मोशन काय म्हटलेली आहे, नॉन युनिफॉर्म मोशन असं म्हटलेली आहे. इट्स व्हेलॉसिटी चेंजेस, इट्स velocity that means displacement divided by time, displacement x divided by t. So its velocity changes with time and therefore average and instantaneous velocity are different. This is the important point. Average velocity and instantaneous velocity is different. This is the important point from this graph we get. Instantaneous velocity is different. Average velocity and instantaneous velocity is different. फर्स्ट ग्राफ मध्ये तो पाहिलेला होता त्यावेळेस ऑब्जेक्ट युनिफॉर्म मोशन मध्ये होता, त्यावेळेस आपल्याला ॲव्हरेज व्हेलॉसिटी आणि इन्स्टंटेनियस व्हेलॉसिटी कशी मिळत होती, सेम मिळत होती. पण ज्यावेळेस ऑब्जेक्ट जो आहे तो ऑब्जेक्ट नॉन युनिफॉर्म मोशन मध्ये असतो त्यावेळेस त्याची ॲव्हरेज व्हेलॉसिटी आणि इन्स्टंटेनियस व्हेलॉसिटी जी आहे ती काय असणार आहे, वेगवेगळी असणार आहे. कारण का, तर ऑब्जेक्ट जो आहे तो ऑब्जेक्ट कसा आहे, नॉन युनिफॉर्म मोशन मध्ये आहे, त्यामुळे त्याचा ॲव्हरेज काढलं आणि इन्स्टंटेनियस ॲट दॅट इन्स्टंट प्रत्येक टाइम इंटरवलला, फॉर एक्झाम्पल T1 टू T2 त्याने डिस्टन्स जे आहे ते डिस्टन्स 2 मीटर कन्सिडर केले, करूया 2 मीटर ट्रॅव्हल केलेले आहे आणि फ्रॉम T2 टू T3 त्याने जे डिस्टन्स आहे ते डिस्टन्स 6 मीटर कव्हर केलेले आहे. ठीक आहे, म्हणजेच अनइक्वल डिस्टन्स त्याने कव्हर केलेले आहे. त्यामुळे प्रत्येक पॉइंटला, प्रत्येक टाइम इंटरवलला तुम्हाला इन्स्टंटेनियस व्हेलॉसिटी जी आहे ती इन्स्टंटेनियस व्हेलॉसिटी डिफरंट मिळणार आहे. जर तुम्ही टोटल पाथ लेंथचा ॲव्हरेज घेतला तर ॲव्हरेज व्हेलॉसिटी सुद्धा तुम्हाला काय मिळणार आहे, डिफरंट मिळणार आहे. सो दिस इज द important point from this graph that we get average velocity and instantaneous velocity is different. This point is important. So average velocity from T1, average velocity from T1 to T4, A to point B. From T1 to T4 we get average velocity. आणि जर तुम्हाला शॉर्ट टाइम इंटरवल मध्ये व्हेलॉसिटी फाइंड आउट करायची असेल तर त्या व्हेलॉसिटीला आपण काय म्हणतो, इन्स्टंटेनियस व्हेलॉसिटी असं म्हणतो. आणि इन्स्टंटेनियस व्हेलॉसिटी आपण T1 टू T2 इथपर्यंत काढू शकतो किंवा T2 टू T3 इथपर्यंत सुद्धा ती इन्स्टंटेनियस व्हेलॉसिटी जी आहे ती इन्स्टंटेनियस व्हेलॉसिटी काढू शकतो. सो these are the different types or 5 types of graphs that the objects can travel in uniform and non-uniform motion. कुठले 5 प्रकार पाहिले तर फर्स्ट टाइप ऑफ मोशन आपण पाहिला दॅट इज ऑब्जेक्ट इज ॲट रेस्ट. सेकंड टाइप ऑफ ग्राफ आपण पाहिलेला आहे ऑब्जेक्ट विथ अ युनिफॉर्म व्हेलॉसिटी. थर्ड टाइप ग्राफ पाहिलेला आहे ऑब्जेक्ट विथ अ युनिफॉर्म व्हेलॉसिटी अलॉंग निगेटिव्ह एक्स ॲक्सिस. फोर्थ टाइप ग्राफ पाहिलेला आहे ऑब्जेक्ट परफॉर्मिंग ऑसिलेटरी मोशन. अँड फिफ्थ टाइप ऑफ ग्राफ पाहिलेला आहे दॅट इज ऑब्जेक्ट इन नॉन युनिफॉर्म मोशन. ठीक आहे, हे 5 वेगवेगळ्या प्रकारचे आपण ग्राफ पाहिलेले ज्याच्या सहाय्याने आपण त्या ऑब्जेक्टची मोशन जी आहे ती मोशन कशा पद्धतीची आहे ते आपण बाय ग्राफ बाय पिक्चर सांगू शकतो आणि त्याचा स्टडी करू शकतो. सो नेक्स्ट पॉइंट आपण पाहणार आहोत दॅट इज द ॲक्सेलरेशन ऑफ अ ऑब्जेक्ट. acceleration आणि acceleration जे आहे ते आपण small letter a ने दाखवतो. then for acceleration a and first we are going to see its definition or study its definition. So definition of acceleration. First definition, that means acceleration is defined as the ratio of change of velocity with time. Rate of change of velocity, rate of change of velocity with respect to time. With respect to time. Rate of change of velocity, that means v2 minus v1 divided by t2 minus t1, which is equal to delta v divided by delta t. Therefore, now change in velocity with respect to time, change in velocity, that means velocity. So again the formula for velocity is change in displacement divided by time, and we know that displacement is a vector quantity. So delta v divided by delta t is also vector quantity. Therefore vector a acceleration or vector a is equal to delta v, vector delta v divided by delta t. This is the formula for changing velocity with respect to time. We call it as a acceleration, and this acceleration we get as a average acceleration. We get as a average acceleration. Vector a is equal to delta v divided by delta t. Delta v is a vector, therefore vector delta v divided by delta t. Now this acceleration is instantaneous also and average also. For instantaneous acceleration and average acceleration there is the same formula. A is equal to change in velocity divided by change in time. But for instantaneous acceleration we use the limitations. Therefore for instantaneous acceleration vector A is equal to limitations of for a short time. Therefore we call it as a instantaneous limitations of delta t tends to 0, delta v divided by delta t. This is the formula for instantaneous acceleration, and this is the formula for average acceleration. So instantaneous acceleration is the limiting value of the average acceleration when the time intervals goes to 0. Time interval जो आहे तो time interval काय असणार आहे goes to 0, that means for a short time. Therefore it is given as limitations of delta t tends to 0, delta v divided by delta t, vector delta v, and this can be write as a vector dv divided by dt. Vector dv divided by dt. Now as displacement time graph, For acceleration, we are going to study the graphical method for velocity and time. We know that velocity and time gives us acceleration. So next point is velocity time graph for four different cases. Velocity time graph. Velocity time in bracket v dash t. Velocity time graph. First case, velocity divided by time will get acceleration. Velocity divided by time will get acceleration. Therefore, we study acceleration using velocity time graph. So first case of a graph is motion of an object with zero acceleration. Object moving with a constant velocity. Object moving with constant velocity. See, along horizontal axis we taken as a t for time axis. Along y-axis we taken as phi. Now we taken as a phi. So with a constant velocity, object is moving with a constant velocity. For example, this is the 0, 0 coordinate and object position is at a point A. The object position at a point A, and as the time passes, for example, we taken as a time in minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes. As the time passes, the object velocity does not changes. That means the object position is same at point A as the time increases. जसं टाइम इनक्रीज होतो तो ऑब्जेक्ट जो आहे तो ऑब्जेक्टची व्हेलॉसिटी जी आहे ती व्हेलॉसिटी काय राहते तीच राहते. व्हेलॉसिटी चेंज होत नाहीये. त्यामुळे व्हेलॉसिटी चेंज होत नाहीये म्हणून आपण काय म्हणतो कॉन्स्टंट व्हेलॉसिटी. वी गेट अ कॉन्स्टंट व्हेलॉसिटी. जर व्हेलॉसिटी कॉन्स्टंट आहे तर त्याचं ॲक्सेलरेशन जे आहे ॲक्सेलरेशन जो आहे तो ॲक्सेलरेशन आपल्याला काय म्हणतोय a इक्वल टू 0. काय म्हणतोय ॲक्सेलरेशन is 0. So from this graph we get the motion of an object with zero acceleration. That is constant velocity. So object moving with a constant velocity, and for this we get the graph like this. This horizontal line is parallel to time axis and we get a is equal to 0. This is the first case of velocity time graph. Object moving with a constant velocity, and the nature of graph is like this. This line is parallel to time axis. So this is the first type of case. Second type of case, that is object with velocity along positive x-axis with uniform acceleration along same direction. ही फर्स्ट केस जी आहे फर्स्ट केस विद्यार्थी समजली का तुम्हाला. या ग्राफ मध्ये आपल्याला व्हेलॉसिटी टाइम ग्राफ जो आहे ती व्हेलॉसिटी कॉन्स्टंट आहे आणि व्हेलॉसिटी कॉन्स्टंट असल्यामुळे आपल्याला त्या ऑब्जेक्टचं ॲक्सेलरेशन जे आहे ते ॲक्सेलरेशन काय मिळत आहे 0 मिळते. ठीक आहे. नेक्स्ट केस जे आहे ते नेक्स्ट केस दॅट इज ऑब्जेक्ट मूव्हिंग विथ व्हेलॉसिटी along positive x-axis with uniform acceleration along the same direction. Second case आपण पाहणार आहोत. B, point B, that is object of acceleration along same direction. Along same direction. For that, we get the graph nature like this. Nature of the graph is like this, and if this is the starting point of velocity, we get different velocity along same direction v1 and v2 as the time increases, and we see the nature of the graph is like this. So up to this point today we stop here. Next we will be continue in next lecture. Thank you.